Hi, I'm here with Clark Smith, who's going to demonstrate an interesting phenomenon that most engineers are not aware of when selecting low-value resistors. So Clark, what are you going to show us today?
I'm going to show you about thermal EMF. Thermal EMF is a phenomenon that occurs anytime two dissimilar metals are joined together. There's a voltage generated. In any metal strip resistor, when they're put together, we have a copper terminal, a resistive metal, and then another copper terminal. So we have two of those junctions, but they're opposite polarities. So normally there's a net zero voltage. But if the temperature of one of those terminals changes above or below the other one, then we'll see a voltage change. So this demonstration shows us that voltage change. And if you want, you can put your finger next to the part there on that terminal. And as you can see, as the heat from your finger goes into the part, we're seeing a voltage change. This is a 30 microvolt scale, and looks like that's going to be a full 30 microvolts. If you want, you can touch the other terminal, and it'll move it back the other way towards zero.
Yeah. And this is all based on body heat, so that's really interesting.
Yeah, it doesn't take a lot of temperature change to do that. Now, this is a competitor's resistor, and you can see that really changes a lot. So we'll take the Vishay Power Metal Strip resistor, and through careful material selection, go ahead, you can put your finger on it again, and through careful material selection, we're able to minimize thermal EMF so that it doesn't have as big an impact on
there's some movement, but not near as much, obviously, as the other.
So
and then make it go back?
Sure.
Okay.
So you're probably asking yourself, well, how is that important, or why is that important? And that becomes important when a circuit designer lays out a board and he happens to have a hot component on one side of a resistor and maybe a cooler side of the board on the other side. So you can see there'd be a temperature differential across that resistor, causing a net voltage to be generated across that current sense resistor. And as the current level might drop through that current sense resistor, the sensed voltage would be lower. So any thermal EMF that would be generated in that resistor would cause a bigger error. So it's a very important thing to consider when selecting resistors.
Oh, that was very interesting. Thanks, Clark.
You're welcome.
This has been a Vishay TechCast. I'm Connie Kersnave, and thanks for watching.